question starts with implicit differentiation. It gave us the function 2x squared plus 3y squared. Woo, we got to take that derivative and prove that that derivative is 2y minus 2x over 3y minus 2x. We can do this. Just don't forget your dy dx's. The derivative of 2x squared is 4x dx dx. The derivative of 3y squared is 6y dy dx. The derivative of negative 4xy is going to use the product rule. And we've got a function f, negative 4, function g of y. So f prime is going to be the derivative of negative 4x is negative 4 times g, negative 4y, plus the derivative of g, which is dy dx, times f, which is negative 4. The derivative of 36 is 0. Let me just remind you guys, this was my f prime, this was my times g, this was my g prime, this was my, it's a good thing I went back to it. This is my f, so I needed to have a 4x there, a minus 4x there. Okay, good catch. So now we've got to go get dy dx by itself. When I do that, I'm going to have 6y dy dx minus 4x dy dx. I'm going to get everything else to the other side, so I'd have a 4y minus a 4x. Whoa, I'm going to factor out a dy dx, leaving me with a 6y minus 4x equal to a 4y minus 4x. Therefore, when I get dy dx by itself, by dividing it out, I have 4x minus, not 4x, 4y minus 4x all over 6y minus 4x. Everything can have a 2 factored out of it. 4y would become 2y, 4x would become 2x, 6y becomes 3y, 4x becomes 2x. And is that what they asked us to prove? It sure is, that my derivatives match. Okay, in part B, they said find the slope of the tangent line to the curve where x is 6. Well, again, we know that this is the slope. So they want us to find that slope when x is 6. But notice that we're going to plug our x in here. We need to plug a y in here, and we don't know what that is. So to find the y, we're going to plug 6 into my function, solve for my y to then be able to plug into my derivative or my slope. All right, so my function is 2x squared plus 3y squared minus 4xy equals 36. I'm going to take that function. I'm going to plug in my x is 6. So I would have 2 times 6 squared and 3y squared minus 4 times 6 times y equals 36. I'm going to have 36 times 2, which is 72, plus 3y squared minus 24y equals 36. I would then have a 3y squared minus 24y equals 36 minus 72, which gets me negative 36. I am trying to solve for my y. Oh, wow, okay. Since they gave us, this is a quadratic, we're going to have to go ahead and set it equal to 0. So I'm going to add my 36 over. Instead of factoring it now, I'm going to factor out the GCF, which is a 3. So then I can just factor this with toot, knowing that it's just a positive 1y squared. What multiplies to be 12 and adds to be negative 8? That's negative 6 and negative 2. Therefore, my y values are going to be 6 and 2. Notice that the question said find the slope value, the slope of the tangent line of the curve at each point on the curve where x is 6. And we've just found, when x is 6, my y is 2 and 6. So notice that, if x is 6, my y is 2 and 6. Interesting. It's not a function, and that's okay. It then says find the slope, and my derivative that they gave me, they want us to find that slope at the point 6, 6. We are also going to need to find that slope at the point when x is 6, my y is 2. My slope was 2y minus 2x over, it's right there. over 3y minus 2x. So when I plug in my x being 6 and my y being 6, that would look like 2 times 6 minus 2 times 6 again, all over 3 times 6 minus 2 times 6. Well, up top we're going to get 12 minus 12, which is 0 over anything, but in this case 18 minus 12 is going to be 6. This gives me a slope of 0. So that's one answer. When we plug in the point 6, 2 to my slope equation, 2 times my y of 2 minus 2 times my x of 6 all over 3 times my y of 2 minus 2 times 6 is going to get me 4 minus 12 over 6 minus 12. 4 minus 12 gets me negative 8 negative sixths, which is positive 4/3. Those are my two answers I'm looking for, 0 and 4/3. All right, find the positive value of x where the curve has a vertical tangent line. Well, on vertical lines, a vertical line looks like this, and it has an undefined slope. You could think of vux. Well, my slope that they gave me was, let me look back real fast, 2y minus 2x, 2y minus 2x over 3y minus 2x. And for that to have an undefined slope, that means that the denominator has to equal 0. All right, so we're going to go find out where is this denominator, whoops-a-daisy, equaling 0. All right, and in this case, we'd have 3y equals 2x, and we got y equals 2/3 x. And it says find a positive value of x at which the function that was 2x squared and 3y squared minus 4xy equals 36. They want us to find an x value. And now that we know that that's happening, every time my y is 2/3 x, I'm going to make a substitution in for my y so we can solve for that x value that they're asking. We've got 2x squared plus 3 times 2/3, forgot my x, squared, minus 4x times another 2/3 x equals 36. I'm going to keep solving. We got a 2x squared and a 3 times 4/9 x squared minus 8/3 x squared equals 36. We've got a 2x squared and a 12/9. 12/9 divided by 3 would be 4/3 x squared minus 8/3 x squared. Convenient, same exponents. Oh, all of them have the same exponent. We're dealing with 2x squared plus 4/3 x squared minus 8/3 x squared. So when I combine like terms, so we got 4 minus 8/3 is negative 4/3 plus 2. 2x squared minus 4/3 x squared equal 36. So that's like saying 6/3 minus 4/3 would be 2/3 x squared equals 36. Dividing by 2/3 is the same as multiplying by 3/2. When I multiply by 3/2, I'd get 18. 18 times 3 is going to get me 54. And the square root of 54, and notice that it could be plus or minus, but in this equation, this question, they said find the positive value of x. So that could be the square root of 54 if you're feeling real fancy and you say, well, I know 9 times 6 is 54, so that's the same as 3 root 6. Either of these answers work. We've got more related rates going on in this question, more implicit differentiation really, but they're giving us some x and y values that we are going to plug and chug into our equation. So it says find dy dx or find dx dt. So that lets me know I need to take a derivative with respect to time. All right, we can do that. The derivative of 2x squared is going to get me 4x, and we typically say dx dx, but in this case, because they want dx dt, the derivative of x with respect to time, or t, is going to be dx dt. The derivative of 3y squared with respect to time is going to be 6y dy dt. Oh my gosh, we've got product rule again, my f and my g. Be careful because we cannot forget that we're differentiating with respect to time. The derivative of negative 4x is going to be negative 4 dx dt times my y. And again, this right here was f prime. This is my g. Plus, now we need to do g prime. The derivative of y with respect to time will be dy dt times my f, which is negative 4x. And just a reminder, this was g prime times my f. The derivative of 36 is 0. Okay, so now it says when t is 1, the value of x is 2. So I'm going to plug in a 2, I'm going to plug in a 2 for every x, a negative 2 for every y, and dy dt is 4. We got to go find dx dt. Plug it in. All right, 4, my x is 2, my dx dt, I don't know. 6, my y is negative 2, my dy dt is 4. Minus 4, my dx dt, I don't know. My y is negative 2. My dy dt is 4 times negative 4. My x was 2 equals 0. Wow. All right. Let's go simplify and get dx dt by itself. We got an 8 dx dt minus, let's see, 12 times 4 is that 48, plus an 8 dx dt. Minus 4 times 4 is 16 times 2 is 32. All right, I'm going to keep my dx dt's on one side. So I've got 8 dx dt and another 8 dx dt, giving me a total of 16 dx dt. I'm going to move my 48 over and my 32 over. 48 and 32 is just going to get me 80. So now I've got to divide by my 16 to get dx dt equals 80 over 16. We could end right there, but that also simplifies to be 5.